You have completed the physical repairs and adjusted the mechanical torques, but the job is not done. Your rig remains suspended above the ocean, and it is not operationally or legally safe until the paperwork proves it can stay there. In this final step of the series, we will master the troubleshooting checklists for failing brakes, calculate torque equalization and static holding capacity, and properly complete the required compliance worksheets. Before you begin, gather your required tools. You need pages 15 and 16 from SOP 307, the physical torque measurements you took from your rig, a pen, and a calculator. These worksheets are your primary evidence. They are the definitive, mathematical proof that your rig's braking system is balanced and capable of surviving the physical loads of a severe offshore storm. We begin with the first major diagnostic scenario, a brake unit that fails to hold its required torque, or one that consistently overheats during normal operation. You must approach this using the exact sequential order of the troubleshooting checklist. Do not skip steps and do not guess. Work from top to bottom. This 12-point checklist shows your required sequence. You start with the primary mechanical faults. Check that the manual release is not stuck. Inspect the friction discs for wear below the minimum thickness, and confirm the hub has not shifted on the shaft. If the mechanics are sound, you move to the alignment and electrical checks. Confirm your solenoid air gap is set between 1¼ and 1½ inches. Then check for loose wiring and measure the coil voltage with a multimeter. The first failed check you encounter on this list is your root cause. Stop immediately and correct it. Fixing the fault here is the only way to prevent a catastrophic mechanical failure when the brake is under load. The second major troubleshooting scenario involves a brake that emits a loud, constant humming noise or repeatedly burns out its solenoid coils. Looking at this 8-point checklist, your initial steps are electrical. Verify that the installed coil rating matches the rig's supply voltage, and check that the air gap is not opened excessively beyond 1½ inches. If those are correct, examine the physical movement components. Worn armature plunger guides or dirty contact surfaces on the solenoid will cause chatter and harmonic vibration, generating that loud hum. You can physically test the overall health of the solenoid mechanism by pressing it down by hand. It should require exactly 20 to 30 pounds of force to manually depress the plunger. Do not ignore a humming brake. That noise is an early warning sign of electrical degradation. Left unresolved, the coil will burn out, potentially trapping the brake in the engaged position during a critical jacking operation. With the brakes functioning correctly, you must balance the physical load they hold. The motor torque worksheet exists for one specific purpose, ensuring the rig's weight is distributed equally across all 12 motors on a single leg. On the motor torque worksheet, first sum up all 12 old pre-adjustment torque readings for the leg. Divide that total sum by 12 to establish the exact mathematical average. Finally, add exactly 3 foot-pounds to find your new torque target for every motor. You must calculate each leg entirely independently. Never take the average from the port leg and apply it to the starboard leg. Equalization prevents single motor overload. Without it, a gear unit carrying excess weight will shatter its bull gears during the stress of a severe offshore storm. Next is the monthly brake holding worksheet. This document is entirely separate from torque equalization. It tracks the static holding capacity of your brake discs to monitor long-term physical wear. On the monthly brake holding worksheet, measure and record the force to slip the shaft clockwise, then counterclockwise. Divide their sum by 2 for the average holding capacity. 20 horsepower motors require a 166 foot-pound minimum. 30 horsepower motors need 313. Lower readings dictate immediate disassembly. Tracking these numbers month over month reveals declining trends in disc friction. This data allows you to schedule preventative maintenance and replace worn discs long before a brake drops below the minimum threshold, securing the rig's stability. To maintain the system's integrity over the long term, log the SOP 307 annual inspection requirement directly into your rig's preventative maintenance system. This annual deep dive is when you evaluate long-term wear trends across the entire system, replace aging seals, and rebuild degrading brake assemblies to establish a safe, reliable operational baseline for the coming year. This image shows your target end state. 2 fully completed, mathematically verified worksheets, signed, dated, and ready for your rig manager's review. That concludes our 10-video series covering the Letourneau and National jacking systems. You can find download links for the motor torque and monthly brake holding worksheets in the description below. Follow the SOP, Document your work accurately and never cut corners on the jacking system. Your precision is the only thing keeping the rig and its crew safely above the water. Stay safe.